Hello everyone, welcome to TRON Core Devs Meeting 3. Today's agenda is firstly, Zachary will give an introduction to multi-signature and the protocol design. After that, Benson will talk about how to operate multi-signature permission in tip 105. Then, Wayne will share his research on comparison with other cryptographic multi-signature schemes and the implementation. At last, Cian will lead us to discuss the optimization of multi-signature from the aspect of the performance. Okay, since last meeting, do you guys who have any updates?
Sure, Bruce. I got some update for our latest proposal 32. Okay?
Okay.
Okay. Just want to introduce proposal 32 a little bit. So last week, Tron Network just approved the proposal 32 for Solidity 0.5.9 functionality upgrade. So this proposal contains several new TVM instructions and new functionalities. And some details are here. In TIP 43, we provide a new pre-compile function to help contract to verify a group of signatures with lower energy and lower CPU time, which is an optimization for easy recovery function. And in TIP 44, we provide a more safer way is contract to judge whether an address is contract or not. And that developer can simply check its contract property for an address object for this purpose. And in TIP 54, now the address.transfer function support transfer TRX to a non-existing address and create a new account for this targeted address. I think this will do a lot more convenience for web developers for the non-existing address transferring case. And for TIP 60, we provide a new pre-compile function to help contract to verify multi-signature messages. This is a special implementation for just Tron accounts. So all the new upgrade is included in java-tron Odyssey 3.6.6. And we strongly recommend you to upgrade your node if you haven't do so, which can avoid out-of-sync problems. So that's all from my side. So anyone have questions?
Okay. Thank you, Tanhao. To keep up with the latest upgrade, what do the app developers need to do?
Okay, so first thing I want to mention is if you are a full node maintainer, you may have to upgrade your full node version to Odyssey 3.6.6, and I'm pretty sure if you didn't do so, you might got out-of-sync problems. So another thing is this proposal is more related to dev developers. If I were dev developers, I may excited about TIP 54 since it can save my energy and lower my cost when I handling exception for transfer function. And also if I have logic about signature validation, especially to validate more than one signatures in a single smart contract transaction, I would like to check TIP 43. So that's my suggestions. Any more questions?
Okay, thank you.
I have a question about the TIP 54.
Okay.
You mean when I transfer TX to an non-existing address, and you will and the java-tron will create a new account for the address.
Yeah.
So whether I need to upgrade to Solidity 0.5.9.
Yes, you have to use the latest compiler, which supports 0.5.9.
If I don't use a new version, will it be compiled as normal?
I see your point. So you mean just so actually you don't have to do the 0.5.9 compiler. It's not necessary, but I still suggest you to do so. As long as you use a full node which supports the latest code, you don't need to worry about anything if you are a developer, that developer, I mean.
Oh, okay, got you. So I have another question. It is still about the TIP 54. transfer TRX and transfer based TRC10 can active the new account for the address?
Yes, I think so.
Okay. Thank you.
Okay. I think you guys can continue.
Okay. Hello, everyone. Well, I'm Zachary. I will tell you something like the basic situations of the multi-signature protocols. Well, as you all know, that normal cryptocurrency transaction requires only one signature, while the multi-signature means the signature is more than one. Okay, it gives every signature a weight. Basically, the total weight must reach something like a customized threshold before executed. While using multi-signature, an account can be managed by several private keys. Well, and the transactions created in a specific account can be signed by several people. Well, I'm going to talk about the specification of multi-signature operation permission and the way to implement user-defined operation permission for multi-signature. Okay? Well, firstly, let's see the protocol design. The relating structures in protocol including account, well, permission, key, and transaction. There are four of them. I'll show you something. You can see? Is my screen okay? First comes to account, and there are three different rows of permission. There are owner, witness, and active. Well, owner has the right to execute all the contracts. Witness is only for super representatives. Well, active contains a set of contract selected execution permissions. Well, next is permission. You can see here is each bit of structure members operations. 1 means true and 0 means not. Here it is. Index refers to the definition of transaction, like, for example, the index of account permission update contract, like that. And the contract type is 46. And next is key. The key includes two members, address, and that is the contrast. It's very simple. Well, weight is the signature weight, okay? And next is transaction. Well, there's a field called permission ID. You can see it's here. The permission ID corresponds to the ID. Well, that is in the permission. Any questions?
Hello.
Yeah.
So, if I increase the system contract in the future, will this line be insufficient? I think this is up to 256 different type of contracts.
Yeah, I got your question. Well, basically, the operation support up to, as you said, up to 256 different type of contract. And for now, the maximum index of the system contract is not more than 50. So, as the number of system contract will not increase very quickly, it is enough within a period of time. It can be very long. Yeah. Okay.
Okay. I got you.
Okay. Then I'm going to talk about different types of permissions. Well, the first is owner permission. It's used to control account ownership and adjust the permission structure. It can execute all the contracts, so it is the top one. Well, owner permission has some other features. There's a default owner if owner permission is none. Well, at a time you create a new account, the address will be added automatically. Okay.
So what the relationship between this owner permission and the owner address field in the account protocol?
Okay, the account field represents the address of the account, which is not allowed to be modified. Well, but you can do it on honor permission.
Oh, so all kind of field just read only. Okay, got you. And so I have account private key, but my owner permission have been given to others. Can I still control this account, or can I access this account?
No. As you just said, your owner permission is given to others. So even if you still have the private key, you cannot sign it.
So at this scenario, the key doesn't work. Only the owner permission work, right?
Yeah, sure.
Okay, got you.
Okay, all good. So let's move on to witness permission. The witness is also called super representatives. We will call them ESA usually. So they can use this kind of permission to manage block producing. Only witness accounts are able to have this permission. So I give you a very simple scenario. When an SR deploys a witness node on a cloud server, and in order to keep this account safe, only producing permission will be given. Well, the account cannot do anything other than producing block, just like something like transfer or So even if the account information is known to others, their possessions will not be lost. Okay. Anything to ask?
Sorry, no.
Okay, so
I have a question. If I don't configure the witness permission, do I need to modify my configuration files?
Okay, I got your question. So, well, basically, if you're not running a witness node, that means you don't have witness permission. So, there's no need to do this. Okay. All right. Next is the active permission. Well, active permission is composed a set of contract execution permission, like creating a new account, transferring, like that. And the most important feature of active permission is that it can customize other permissions. For example, you can allow others to freeze or unfreeze your possessions and give the transfer right to separate people. Well, there's one thing need to be noticed is that if you have the active permission to execute permission of account permission update contract, well, you have the highest permission. So this requires special attention.
So just like upgrade permission to owner permission, which is the highest one. But is that security enough? Is there any problem with the security, something like that?
Well, we offer a high degree of flexibility. But as long as you pay attention when setting permissions, set active permission of account permission update contract to false, there will be no problem.
Excuse me, I have one question. So if I use the account permission update contract to active permission, can I reverse the permission?
Yes. You can use account permission update contract to revert it again.
Okay, so how many multi-signature transactions are there in the TRON network now?
I have not statistics the data. Well, after this meeting, I will publish the specific data. So sorry for that.
Okay, never mind. Thank you.
Okay. No other questions. So that's basically all from me. Thank you.
Okay, thanks, Zachary. Okay, now I would like to talk about multi-signature permission operation. It is proposed on TIP 105. Currently, it's still in draft phase. Let me share the TIP 105. Please wait a minute. Can you see my screen now?
Yeah, Benson. Actually, I got one question here. And so can you just give us some details, knowledge about what's the relationship between TIP 16 you just mentioned and this TIP 105?
Okay. TIP 105 is a supplement of TIP 16. It describes how multi-signature permission is managed. There might be some overlap between Sakharin's introduction. So Sakharin introduced the three types of permission. So it's to implement this, as you can see from my screen, three attributes were added to account. They are owner underlying permission, witness underlying permission, and active underlying permission. At the same time, three attributes were also added to permission. They are threshold, operations, and keys.
I want to know what do these three members mean?
Okay, the threshold means it indicates the threshold of the signature weight. The key includes two parts, the address and the weight, as Sakharin also mentioned previously. And the member operation has 32 bytes, which means 256 bits. Each bit of the operation represents one contract type, and the value of that bit represents the permission of that contract type.
So you mean they are totally 256, which means at most they have 226 contract type. So I have a question for you. Is that enough in the future? Maybe make sure I mentioned this before.
Yeah. Sakharin also mentioned it before. So we have now predefined 32 contract type. I would say it is far away from 256. As Sakharin mentioned previously, the number of system contracts will not increase very quickly. So basically, we would say there will be no risk in short term. And of course, we will look for long-term solution if it's close to 256.
What are the contract types defined at present, and how to define it in operations?
Okay, here you can see the contract type definition list. Currently, we have account create contract, transfer contract, transfer asset contract, and so on. The operation value is used to define the permissions. I will introduce how it works. So each bit of the operation represents the one contract type. Here you can see the first bit represents this account create contract, and the second bit represents transfer contract. For example, if the value of the first bit equals 1, it means that the user has account create contract permission. If the value of the second bit equals 0, it means the transfer contract is not allowed. Okay. So basically, by this rule, the operation value will be generated based on selected permissions. And here you can find more technical details if you are interested. And last, one note for all of you. So please pay attention to this account permission update contract. Once user gets this permission, they can modify all the permissions.
Okay, so I see your point. And can you just summarize, so what's the advantage of TIP 105?
Okay, with this TIP 105, the account permission management will be much more flexible, and it can meet different requirements of the permission management.
Okay, so you just mentioned the account permission update contract. So how can someone just change the permission?
Generally speaking, it will be divided into 4 steps. So the first, the user need to call this get account function to get the original permission data. The second step, user need to change the permission data. And the third step, build a new transaction and sign it. The last step, send the transaction to the blockchain. The permission will be updated accordingly later.
Oh, okay, I see, Benson. Thank you.
Any question? If no, that is almost my part. I will move to next stakeholder and stop sharing. Thanks.
Okay, now let's talk about the comparisons of multi-signature implementations from cryptographic view.
So, explicit cryptographic algorithm of TRON multi-signature implementation.
Okay, TRON multi-signature is based on ECDSA signature. The full name of it is elliptic curve digital signature algorithm. It's a variant of the digital signature algorithm, which uses elliptic curve cryptography.
And what about its security?
Its security is based on the elliptic curve decreed logarithm. The signature of ECDSA consists of two scalars, usually called R and S. It's simple and easy to implement.
So are there any other cryptographic technology which can implement the multi-signature?
As I know, there are two other cryptographic algorithms that can be used for multi-signature. They are Schnorr signature and BLS signature. All of them are elliptic curve signature.
Okay, we now got one question. What's the difference for the ECDSA, the Schnorr, and the BLS?
Okay, Schnorr signature is similar with ECDSA in algorithm structure, but its signature consists of one elliptic curve point and one scalar.
And what's the advantages and disadvantages of the Schnorr signature?
Schnorr can implement the batch signature verification, key aggregation, and the multi-signature, but it requires multiple rounds of interaction between the signers during multi-signature implementation. Furthermore, the M of N multi-signature needs to concrete the Merkle tree and leads to space cost. So I would say Schnorr multi-signature is not efficient in practical use.
And what about the BLS signature?
Okay. BIS signature is based on elliptic curve and bilinear pairings. It can implement the signature aggregation, key aggregation, and multi-signature. BLS algorithm is quite simple. The signature result is only one elliptic curve point.
Okay, can ECDSA be replaced by BLS in TRON multi-signature?
BLS do have many advantages. However, it is not perfect. It requires parameters initialized, and the bilinear pairing in BLS is very complex. It is not efficient in practice. Further optimization is needed if we want to use it.
I have heard about that. BLS is utilized in Ethereum for multi-signature implementation. Do you know why do they choose BLS?
Actually, BLS algorithm is simple and easy to implement. The low efficiency is related to ECSA. If you don't care much about the efficiency, it should be okay to use it. So in a word, the ECSA is simple and efficient compared to Schnorr and BLS signature. That is why it is used in TRON. So, any questions, Manmo?
No, I think.
Okay. So I will talk the next topic. I will compare with other application with other.
Sorry, I have a question.
Okay.
How does the multi-signature is implemented where the multiple users send the same message in parallel, or they send the message with previous signature one by one in order?
In TRON multi-signature implementation, multi-users send the same message, so they can do it in parallel, and the multi-signature just put the separate signature together.
So when the multi-signature will be collected together?
You mean when it is put the signature together?
Yes. The last one will connect the separate signature.
Actually, it is the next one before. For example, we have 3 people. When the first one stands, we can call it A, and the second one, it is based on the previous standard state, you know. So after B signs, and the signatures will be A and B. So if the last user sign, the signature will be A, B, C. So actually, it is the next one. We will put the previous user's sign. Okay.
But I think this is one by one.
Yes, one by one.
Yeah, I think so. Yes, one by one. What you mentioned parallel.
The latter will use the former data and the signature data.
So actually now you can do it one by one, and you can put all the signature together, but you must get all the signs. Okay.
Okay.
Hello, William. I have a question.
Okay.
That means TRON multi-signature support to sign in sequence.
Yeah.
For example, in a company, to apply for expense report, employees sign an expense report first. Then after that, the manager needs to sign to remove, and then the accountant to sign. And after many other signatures, finally it reaches to the VP.
Then can you repeat your question? I don't.
I mean, TRON multi-signature support users to sign in sequence, right? To sign in order.
Yeah.
Yeah, like only after A signs the transaction, B can sign it, right?
No. You can do it in parallel, and you can sign it one by one. So it did not only do it in order. You can do in parallel.
No. I mean, in real.
So what they say, they have no any dependency between the different users. Different users sign the signature. I guess so they can do it parallel, right?
Yes. So actually it is not depends the previous, but you can do it.
So after all the user finish the signature, so you just put they together, right?
Yes.
Okay. I guess that's the idea.
So the signatures are independent.
No. Yeah. Independent.
Oh yes.
Yeah, it is independent.
Okay. I understand.
Okay, thank you. So in the past, I did some research on some other applications in blockchain industry. And essentially speaking, the multi-signature functions in BTC, ETH, and US and TRON are the same. They both want to resolve the problem of controlling access by multiple people and to enhance its security. But for the implementation, they also have some differences. And for BTC, it is called M of N multisig, which means a public key script that provides M number of public keys and requires the corresponding signature script provide M minimum number of signatures corresponding to the provided public keys, and M is no longer than N.
Okay, so is there any difference in use of BTC multi-signature?
Before we use multi-signature in BTC, we should create M of M redeem script by using M public keys, and use this script to do multi-signature.
So can you explain a little bit what about the M of N, something like that?
So as I mentioned before, M is the minimum number you must assign, and N is all the users together. So if you have N users, and you must define the M public key, or you must use the M user to sign the transaction data.
Okay. So minimum. So they totally have M user, right?
The total have N. We have
N user.
Yes.
Okay. What about M?
M is the number you must assign.
Okay.
Yeah.
So what the relationship between the M and N? So N must be greater than M?
Yeah, the M is must included in the N.
Okay.
Okay.
Gotcha.
Okay.
Cool.
In other words, isn't the multi-signature or ETH provided by the system?
As far as I know, ETH only provides basic structure verification operations for contract calls. So it uses a smart contract to implement multi-signature, and the user should write a smart contract by themselves. Okay. So for US, the multi-signature is similar with TRON in some aspects. It also has permission weight and threshold, but in the permission, every account has 2 default named permissions when created. It is owner and active. They have a parent and child relationship by default. Although this can be customized by adding other permission levels and hierarchies. As a result, the active permission can't do anything the owner permission can, except changing the keys associated with the owner. More than that, it allows to create custom hierarchical permissions that stem from the owner permission. Each account's permission can be linked to an authority table, which is used to determine whether a given action authorization can be satisfied. It's similar to the operation space in TRON. So in conclusion, we just talk about the implementation in other blockchain industry briefly, not include the details.
Okay, hello, William. What feature of TRON multi-signature is unique compared to others, and what's the innovation?
That's a good question. Actually, multi-signature is relatively mature. Each blockchain implements it depends on its own basic technologies, such as the account model and the transaction. In generally, TRON multi-signature is very flexible and it can handle it very easily. You can study how to use it in a very short time. It uses operation information to determine which type of transaction can be signed by which permission, and users can change it by themselves, and the users have the full control. More than that, we provide the witness permission for SR to solve their special problems. We specify witness permission for SR. Authorized use can only generate blocks but nothing. So it's very useful in maintenance good node.
Okay, thank you, William. We need to talk about the possible optimization of multi-signature.
Yes. Performance is a particular concern in the selection of our solution, since we do not use the aggregate signatures. So if multiple people sign a transaction, we will face the problem of verifying multi-signature in one transaction. So we need to discuss how to improve the performance. Currently, TRON have limited the number of signatures for a transaction.
But I think just by limiting the number of signatures does not seem to be a perfect solution and may cause restrictions on using. What do you think?
Yes, you're right, but the current limit is not too small, so it will be able to meet the most use case. And we also adopted a method of verifying signatures in parallel.
Okay, so can you explain in specific how is this implemented?
This problem involves a specific code. Let me briefly describe. We divide all transactions in a block into two parts for execution. First, perform signature verification together, and then perform specific tasks such as transferring, freezing. The former part is parallel, and the later part is serial.
So why the verification and execution cannot run in parallel?
Because verifying the signature doesn't change the date in the database, which is stateless, but the execution process changes the states, so it must be serial.
Okay, can you talk more about how to implement the parallelism in the code?
This may be a bit detailed, but it doesn't matter. It's actually a thread pool, and the signature of each transaction is given to a thread to verify.
One transaction is given to one thread. If a transaction contains multiple signatures, then the transaction may take longer time to execute it for the signature compared to the other transaction. It seems it doesn't solve the problem. Is it better that one signature is executed by one thread?
The scheme you said is feasible, but actually the effect is the same. For example, there are more than 100 transactions in a block, most of which are ordinary transactions. A node assume have like 16 cores, and the thread needs to perform about 10 tasks, and one or two threads may only process two multi-signature transactions. So I think there will not be an increase in overall time.
I think aggregate signature is a good way to break the number limits of multi-signatures with high efficiency. Maybe you can use it to optimize the performance.
Yeah. It sounds like a good idea. Aggregate signature is efficient for batch signature verification. We may need further research to see whether they are fit for multi-signature.
Okay, I've heard that ETH 2.0 has adopted the BLS aggregation signature scheme. Have you considered it?
BLS aggregation signatures are very actuative, and we have been paying attention. But this solution is not perfect, such as a longer verification time, which is an order of magnitude slower than ECDSA. We also believe that efficiency issues will eventually be resolved. So I think this part is done.
Oh, okay. Thank you,
Hello, Bruce. I have just one more question about that you mentioned before. Some gas question. You mentioned it does not increasing overall time. So can you explain a little bit? Because I'm not so understanding it very well. You just give an example.
You are asking Cian, right? Not me, right?
Oh yeah. Sorry. Yeah. She give an example about how she do it to prove that it does not increasing in overall time. And then can you give more detail about that example? How it work? I mean, yeah.
You mean the date? Like a performance test?
Yeah. You mentioned that someone have a 16 core, and then some thread for 10 tasks, and then something like that, and then you give a conclusion that you are not increasing in overall time, right? How? And then can you give more detail?
Actually, I think you can get that by the example I have mentioned. You can get that from that aggregation. Right now, I do not have many data. Maybe you can post that on GitHub, or we can discuss later.
Okay, sure. I will do some research about it. It's interesting topic. Okay.
Okay, hello, Sian. I have a question. We use the multi-signature in real scenarios, like I sign a transaction, and this transaction also need Benson, like all Zachary's signature. So I need to send the transaction to Benson or Zachary through Slack or other communication apps. Is there a way Benson can receive a sign notice automatically in their wallet after I sign and broadcast the transaction?
Actually, I think right now many major DApp like TRON or TRON has support multi-signature. You can use that.
Yes, but it is. I think it is a centralized service. I want a decentralized service. It is a blockchain spirit, right? Yeah. So is it possible to give the transaction a status on the blockchain, like a transaction is waiting Benson to sign, like that?
Actually, technically, it's possible, but TRON is not supported yet. In technically, it's okay.
Okay, it is possible, right? Yeah. Okay.
But I think do that offline is more easy.
Okay. And can you tell me how the multi-signature performance impacts on TPS? Like, if 10% of the transaction newly generated on the blockchain are multi-signature transaction, how will the TPS be slowed down?
I think if there are limited multi-signature transaction in a block, it will not lose too much performance.
Okay, that is just an extreme example from me. Yes.
Yeah.
Okay. So does anyone who have some question? Okay, I think that's pretty much all we need to talk about today. For the next meeting, I think Crypto yesterday he emailed me. He wants to discuss the bad node actors, like how to penalize the ones dropping blocks or not acting in time. I think that is a good topic. If there's something you want to talk about or to discuss, you can write the topic on the agenda issue of the meeting form after I create the issue. Okay?
Okay.
Okay, so today's meeting content will be noted and published on GitHub. Okay, any questions before I move on?
No more.
Okay, our meeting ends here. Have a good day. See you guys.
See you. Thank you.